Here we have a function, we need to find its domain and its range. Now whenever you see a cos x, it is time for celebrations because cos x is an extremely well behaved function. No tantrums, no drama at all. Why is that? If you take not this function, if you just concentrate on cos x, what is the domain of just cos x? What is the domain? It is all of those x for which cos x is a real number. Now, why do we say that it is a very good trigonometric function? Your x can take any value. Your domain is the entire set of real numbers. Your x can take any value. Your x can be an acute angle, an obtuse angle, a right angle, a reflex angle, whatever your x is, your cos x is going to be a real number. Not only is it going to be a real number, you can locate it inside -1, 1. Cos x will always lie between this very small interval. There is no angle in this world for which cos x can be, say, 2. There is no such angle in this world. Whatever your x is, however big, however small, your cos x will always be a real number and it will always lie between -1 and 1, which means what? The domain is the entire set of real numbers. And now cos x is not the only one with such good credentials. It is the same with the sin x also. If you take sin x also, its domain is going to be the entire set of real numbers. You can take whatever value for x that you want. Its range, its range is always going to be from -1 to 1. Its value, the final value, the sin x value is still going to lie only between -1 and 1. But then the other 4 trigonometric ratios, they are not this well behaved. For example, if you take tan x and sec x, both of them have a cos x in their denominator, which means what? This x cannot be, for example, it cannot be 90 degrees. It cannot take that value. Why is that? Because cos of 90 is 0. So what you are having is 1 by 0. We cannot have a rational number with the denominator 0 because it will tend to infinity. So this secant x cannot take certain values. It cannot be 90. It cannot be any odd multiple of 90. So it comes with a restriction. It cannot be the whole set of real numbers. No, it has to leave out. There are some values that this x cannot take. But then fortunately what we have here is the cos x. Whenever you see a cos x, a sin x, it's time for celebrations. The domain is going to be the entire real number line. But then there is a problem here. What we have here, our function here is not cos x. What is the function that we have? It is -4 into cos x plus 10. But the good news is the domain remains the same. The domain is still the entire set of real numbers. You don't have to leave out any number, any angle. Can you tell me why that is? So whenever you have a function and then you multiply it with a non-zero constant, you add a constant, you subtract a constant, good news is that the domain remains as it is. The domain does not change because we are only multiplying with a constant, with a non-zero constant. You are only adding a constant. So the domain remains unchanged. The domain of this function is the same as the domain of a plain cos x. But then remember, the input remains the same, but the output changes. Not only for this particular case, that is a general rule. Your input, your x values, or in other words, your domain will be same if you multiply it with a non-zero constant, if you add a non-zero constant to it. But then your output, or in other words, the y values or the range is going to change. Now without writing down the steps and all, just looking at it, we should be able to tell. Why is that? What are the values that the cos x can take? It can take values from -1 to 1. Its minimum value is -1, maximum value is 1. Put the maximum value here, what do you get? You get a -2. Put the minimum value here, what do you get? You get a 6. So therefore your range of this whole function is going to be minus 2 to 6. But then let us write down the steps and do it the legit way. So the cos x lies between minus 1 and 1, but what you need is not the limits for cos x. That is not our function here. This is our function. So what do? Multiply throughout with minus 4. When you multiply or divide with a negative number, what happens? The inequality flips. So let us multiply each and every term with a minus 4. So this becomes 4 and the inequality changes. Here also the inequality flips. Are we done? No, there's still a plus 2. We will add a plus 2 throughout. So there. Have we got our fx? Good news, we have got it. There. So this is the range that we were looking for. This is our range. This f of x can take values only from minus 2 to 6, whereas the good news is the domain, there is absolutely no restrictions. It can be any real number under the sun. That is all for today. You take care. Assalamu alaikum.